This conference will now be recorded.
Hi everyone, let's start this session. So let me introduce myself. Myself Kalyan, I'm the trainer here. So I'm having a 14 plus of IT experience coming to the ORIENIT from 2012 onwards. I'm giving the Hadoop training, and from 2016 onwards, I'm also giving the Spark training. And this year we started like what combination of these two cores as per the industry needs. No? Whatever the technologies is required in the big data, we just combine and we make it as a bigger course now. So that's the intention of the this session to give an idea. So before I go with the more internals about this course, no. So nowadays everyone is like playing with the internet now. So and also the technology is there from like what long time on the big data also. Most of the companies are already playing on now. So just can you please tell me anyone from your point of view, what is exactly you are feeling as a big data? So what are the challenges are there? Why we need to learn these technologies? Before I convey from my end, like what can you please share your thoughts now just for interaction? I want to make my session should be interactive, no, instead of only saying from me. And you can just share your thoughts now. Based on that, I'll understand like what, so how much you are comfortable right now, and I can go into more internals to explain that points now. So, is anyone want to share their thoughts now? What is big data? Anyone, please unmute yourself. You can just give one line, two line statements, also fine.
Big data is a huge data which cannot be processed with the traditional technologies that we have.
Good. It's a valid statement. Good. Anyone else want to share their thoughts? Please unmute yourself just for interaction, okay? It may be 100% right is not, I'm not expecting, okay? Just what you might be thinking, like what, because you're coming for this demo means at least if someone might be said to you like what big data, you might be googled it. Whatever the thoughts you have it in your mind, just expose it. Okay, no problem. But make sure that like what whenever I'm discussing something like what, if you are not clear on that, please raise your voice now. I'll be going to repeat it, or else put in the chat box like whatever the question you have it now. I'll just verify it in a meanwhile, like what in short interval was I'll go. So my session should be like what I want to make it always an interactive, no. I'll just go step by step whenever there is a logical topic is completed now. I'll wait for your questions now. Once that is clear now, I'll go for the next way. That's the same pattern I'll go for the course also that way. So everything will be like what step by step clear in stuff like what completely explaining everything at the end like what asking for questions. It is not realistic now because the connectivity you will be missing it now. Okay, so let's start with the first of all, what is exactly big data? So what is the industry need now? Why we need to learn this course also? So that is what, let me concentrate first now. Big data, the name itself having some meaning now. So whatever the data we are talking about, it is not small, it's a very huge. So general definition like what people will define with respect to three V's, but not only three V's now, we have more now. But what are the primary three V's are volume, velocity, variety. So these are the primary three ways now. But not only this, we have vulnerability, value of the data, veracity of the data, like this, like what some other primary other ways also. But what exactly this three ways primarily talks about is there are two problems now. One is storage problem, second one is processing. There are two problems are there. First main problem is storage, second problem is processing. Let's spend some time on like what to understand the terminology, whatever I have written here now. So volume. Volume is like what? Size of the data. The data size like what? Bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, zettabytes, like this now. Okay, the volume of the data when we are talking about with respect to big data is like small volume like bytes, kilobytes, megabytes. This is not a big data. It's a data, but it is not that big data like what industry expecting. So the big data mostly like what some of the use cases are starting with like what gigabytes of the data, terabytes of the data, petabytes of the data, exabytes of the data, zettabytes of the data now. So that is the volume like what big data is primarily talking about. It might be kilobytes, megabytes, gigabytes. It's not really, not always like what that is a big data problem. It depends on the complexity of the problem, but that is not a big data problem. Volume, this is what exactly what it defined now. And second thing is velocity, speed of the data. How speed the data is generating it now. So we are saying like what 1 MB data, 1 GB data, 1 TB data. But how fastly that data is generating now? Maybe per day 1 GB data. There are some use cases, okay? Maybe some use cases, maybe like what per day 1 TB data. Maybe there are some use cases like what per day might be 1 petabyte data also. It depends on. So here we are going to talk about like what velocity, because we have the how much volume of the data and how much duration it is taking, based on that the speed we will be going to calculating here now. So if this is a per day 1 GB data for a small scale applications like what, this is a huge amount of data, but large scale application like what per day 1 GB is like what, very small. It's not even considered now. If you talk about Facebook or maybe like WhatsApp, Telegram, all these applications like what, they are getting the data like what per day nearly petabytes and more than petabytes also. If you talk about the applications what we are playing like what, they are getting per day itself only petabytes of the data. So that is the huge volume now. So when you go this much volume like what in a certain months or year like what, the data will be like what exabytes, zettabytes now. So the realistic use cases, if you take it like what in India, Hyderabad itself, only like what in entire Hyderabad, like what we have so many cameras are there now. So more than like what 25,000 cameras are there now. Okay. So suppose if you calculate like what the volume of the data, how much they are storing per day, think about now. Okay. If one camera might be recording for 24 hours now, for every hour, if you take it like what least number is 1 GB. Okay, so let's do some calculations now. One camera for 1 day, how much is 24 hours? So for every hour like what, approximately 1 GB data means it is 24 GB data per day. On camera just 24 GB per day. So like this, like what, they have more than 25,000 cameras are there now. Just for 1 day itself only, how much you can think about now? Approximately, anyone? The number you can approximate number. 25 into 24. Let's do. Just a second. My system is a little slow. So we are having like what, 6 lakhs GB. So now if you are translating into a TBs like what, by just doing like what 1024, and we can also take it like 1000 approximately, then this will be 600 TB per day. Approximately we are getting it like what, 600 TB, that too in just Hyderabad, like what I'm talking about. Like this throughout the world, and people like what, how many big countries are there, states are there, like what, every place they are maintaining it now. How much volume of the data people are generating, like what, think about now. Okay, so this data, why this much volume is because of this variety. So there are three varieties of the data: structure, semi-structure, unstructured. So we have primarily three varieties of the data: structured, semi-structured, unstructured. Now, so if we are going for structure, the examples like RDBMS table and Excel sheet are the best example for structure. Suppose if we are going for semi-structured data, the examples are XML files, and nowadays is like what, JSON. In big data there are some other formats also you will be going to see now. And when it comes to unstructured data, like what, we will be seeing more varieties of the data. So those are like what, images, videos, audio file, GIF file, PDF file, docx file, like this, so much of variety of the data. So where exactly big data primarily having a main problem is this unstructured data. So this 600 TB data, what we are talking about, is also comes under unstructured data, the video format. The data is like what, in a video format. It might be they're taken some screenshots, means like what, the capturing the image may not be this much. Okay, maybe if they written some kind of text format, like what, may not be this much. So huge volume of the data is generating only because of like what, we are using like what, more unstructured data in your mobile also. Like what, in older days, if you have 2 GB 3 GB also, people are happy for like what, 2 3 years. But now 2 GB is not even sufficient for one day also, because if you start recording some video, like what, that itself will be like what, more than 1 GB or 2 GB now. Suppose if I take this session itself only, it's end of this session, like what, the size of the video will be around like what, 1 GB plus only. Okay, so the huge volume of the data we are generating, so due to like what, people are playing on like what, internet, and also like what, the technology, like what, mainly we are capturing the high-end resolution images and videos, and also like what, in other formats like what, PDFs also, like some encryption things. No, every place the data volume is generating now. So big data is primarily pointing is just not about the format of the data, it is always talking about combination of these three things. Okay, your data might be a small or large. It might be coming with the low speed, or it might be coming with the high speed now. It can be any format of the data. So what is the first problem it is pointing is, do we have any solution for storage? So when it comes to the answer for the traditional approach, like what, RDBMS is, RDBMS is a answer for this big data problem is 100% no. So why it is no, like what, if you take this example only, this much of data in RDBMS we can't store now. And generally RDBMS meant for to handle the structured data, not for like what, unstructured semi-structured data. So that is also one more reason. So maybe suppose if you went also, maximum how much data you store it in RDBMS, like what, maximum some terabytes no, but not like a hundreds of the terabytes, is petabytes is not the one, maximum 10 20 like that no. So that means if I go for RDBMS one day also, I cannot go for solving this problem now. Intention is clear now here. So people are looking for like what, some alternative solution. Now those solutions we call it as a big data solution. This course is mainly meant for like what, learning those solutions, understanding the more internals about this problem, because this is a demo session, just as an overview point of view we are learning it now, but we also need to understand this problem like what, more in depth. That is what in the course we'll be going to knowing it now. So first problem is this, and the second problem is, assume it somehow you store the data. So whatever the data you have stored it, like what, are you able to process it or not? Generally we will be going to process the data in a two ways: sequential, parallel. Which is the best way is like what, parallel processing now. Sequential is like what, more time taken now, parallel will be like what, less. So are we able to process the data now? Whatever the data we store now, are we able to process or not? If any solution is able to process that one, that is called as a big data processing solution. If anyone providing both the solution, that is called as a big data solution. In big data, we have some storage solutions are there, some processing solutions are there, some of them supporting both also, some of them supporting both also. In that, the first solution like what very famous in the market is Hadoop. When you say people like what big data, why they say name is Hadoop is like what the primary solution, the initial solution for like what this problem still today also in the market is like what Hadoop. Now that's the reason like what. Similarly like what, if I ask a question like what, so I ask you to search something, where are you searching it like what, you will say Google. But is the Google is the only search engine? Means not. We have a Yahoo is there, Amazon is there, Bing is there, and so many other search engines are there now. But why we are saying the first name is like what Google is, which very famous, most of the people are using it now. Same concept here also. In big data there are plenty of solutions are there, but why people will say big data solution, the name is first one is Hadoop. Means Hadoop is the primary solution, still market leader. Is everyone is clear till this point now? Before I talk about what is exactly Hadoop, how it is solving now, before I go there, is everyone is clear what is the primary problem of big data? Any questions on that? If something is not clear, you can just let me know. I'll clarify. Otherwise, I'll continue on the what is Hadoop now. Okay, you can just put yes or no in the chat also. Just give me an idea for that. Okay. Okay, fine. There are no questions. Then let me continue. So Hadoop is from like what Apache. What is this? Apache is a organization. Like Oracle is a company, IBM is a company. Like this, these are the companies now. Okay. So, but coming to Apache is not a company; it is an organization. In software world like what most of the solutions we build from this Apache products only. Okay, under Apache organization more than 100 projects are available. In that, the first project what we are talking about very famous with respect to big data is Hadoop. We call it as a Apache Hadoop. So Apache organization like what, whatever the product is there, it's a freeware. You can just simply go to that website and you can feel free to download the software, or you want to download the source code also, you can feel free to download the source code, and you want to modify that source code as per your business requirement, and you want to use that product for like what commercial means, you can. But you cannot make Hadoop as a commercial now. On top of that Hadoop like what, whatever you build, that solution can be commercial, but Hadoop is not a commercial. Okay, the main advantage of this Apache products like what, cost cutting. Nowadays every company is going for open source technologies. The main reason is like what, cost cutting. If you reduce the product cost, they can sell more people. Okay, assume it like what, I build a one product now, the cost of the product is like what, 1 lakh. Okay, because I have added like what so many features to that, but and I also have some paid solution is there. So the 1 lakh is like what, buying people are like a very less, but the same product almost all features with maybe one or two minimal like what there in the, maybe just for 10,000 rupees only the product now, then buying this 10,000 product is like what, more people will be going to buy. Why? Because like what is almost comparatively same, almost comparatively same to 1 lakh no, but there are some features maybe there no. So that is a place like what people are doing it like what, they will take this cheaper solution freeware now, and they will try to add like what are the missing things now, they develop it and they are selling it now. So that is what right now current trend in the market now. Okay, why everyone is asking to learn the open source technologies like what, first reason is cost cutting, and second reason is like what, easy to develop your solution also. Why easy to develop it like what, so whatever the important features you want to develop as part of your product like what, some of the features they are already providing now, so then you don't need to re-implement now. If you start implementing like what, it may take 1 year now, unnecessary time waste. Within a short time you want to solve your problem is like what, try to use the open source technologies. This is very very important now. Okay, in older days like what, this trend is not that much, but almost like what, last 10 years people are all are playing with like what, open source technologies. The reason is like what, these people are building some base stuff now, utilizing that you can solve your problem. Hope everyone is clear like what is the main purpose of the open source technologies now. Okay, and coming to Apache Hadoop having a three main components now. First component is HDFS, second component is MR, third component is yarn. Let me just make a note on some of the points here, then I'll explain now. HDFS means Hadoop distributed file system, meant for distributed storage. MR is map reduce, meant for distributed parallel processing. Yarn, yet another resource negotiator, and the main purpose is resource management. So learning a Hadoop means like what, we need to understand like what, these are the three components now. So HDFS is the primary component, then second one is the MR, third one is the yarn. So what is exactly this HDFS and how it is differ from the traditional one? Let me give you an idea on this. This is what exactly first thing we need to be clear at least some extent now. Okay, FS is normal file system in our laptops and like what systems, or maybe the servers, wherever is like what we are storing the data in a normal file system. So what is exactly drawback with the traditional file system is like what, hardware limitation. Having a hardware limitation example is, I have a laptop with 1 TB hard disk and 16 GB RAM. 1 TB hard disk, 16 GB RAM. So with this system configuration, like what, maximum I can store only like what, 1 TB data. Okay, and I also have like what, my system having a 2 USB slots now. So then what I can do like what, I can connect like what through USB drives like what, through external hard disk now. Then maybe like what, 1 TB, 1 TB, extra 2 TB, maybe like what, 3 TB. If I have maybe more external hard disk, maybe 5 TB one now. Maybe I can store like what, I can access, it is not storing now. I can access like what at a time, maybe like what, 10 TB also. But is it possible to handle like what, petabytes, exabytes of the data? Means no. That's the limitation of traditional file system. Whatever the laptops, desktops we have it now, we have the storage problem with respect to use volume. To address this problem, industry started like what, around 1995, those years itself only, DFS. What is the concept of DFS? Is distributed file system. Distributed file system. What is the main concept of this distributed file system is, instead of going with the one system, instead of going with the one system, so we will take like what, n number of systems. That n can be more than 1, 2, 4, 10, 100,000, whatever it may be. Okay, so n number of systems, and all these systems will be connected over the network. The first primary condition is like what, you have n number of systems are there, all those systems are connected over the network, and after that like what, there will be a sharing is enabled between all these system now. So that type of systems is called as a distributed file system. So what is the advantage we will get in this distributed file system is, in first system I can store 1 TB data, in second system I can store 1 TB data. Like this I have a 10 systems are there, 10 TB data I can store it in a distributed manner. In a single system I can't store 10 TB, but if you have n number of system, you can able to do it in a distributed manner. Is that point is clear now? The primary difference between the FS to DFS is like what? FS, you cannot store large amount of data because that's a hardware limitation. So same thing is also in DFS, no? But in DFS, what technique is we are following like what? We will connecting the systems over the network now. Connecting the systems over the network and enabling the sharing between them. So due to that, like what, I can able to access the data over the network like what other systems also. Like that, I can store somewhat large amount of data. But still, there are certain challenges are there now. Okay, there are certain challenges are there in this DFS. To overcome that, like what, Hadoop introduced the concept called HDFS. Hadoop introduced the concept called HDFS. What is the main purpose of this HDFS is, it is also a same as like DFS concept, but on top of that, we will be installing the Hadoop software now. You have n number of systems are there now. In all the systems like what, we will install the Hadoop software. So once we install the Hadoop software, like what advantages this HDFS is giving is like what, if you want to store like what n number of records, maybe like what, it can be a small files or large files, no, it doesn't matter. What HDFS will do like what, it will distribute the data across the machines now. The first primary problem in DFS like what, as a person always need to sit into the systems like what, he need to validate is the space is available or not. Okay, I have 10 systems, I said no. Okay, initially like what, 500 200 300 randomly you store the data. Later, whenever you are storing the second file like what, you should also know how much free space is left in that system. That is the biggest challenge. Okay, just for 10 systems, maybe like what I can spend in a 5-10 minutes now, but think about 100 systems are there, 1 lakh systems are there, and identifying like what, how much free space is there, like it's very difficult now. So to handle these type of problems like what, Hadoop introduced a software concept here. Instead of directly like no, we'll install the Hadoop software there no, then that will take care of like what, based on your instruction. Okay, I want to store 10 TB data, it look at based on the statistics whatever it is maintained by Hadoop, no, it look at and says like what, yes, you can store this 10 TB data. Maybe like you ask me like 100 TB data, yes, you can store it now. 1 petabyte you can. So whichever is not possible, it clearly mentioned like what, so I'm not able to store it now, I can only store this much of data only. That information will be going to give it to you, and based on that, what Hadoop admins will do like what, they will scale up the Hadoop cluster as much as. So today I have started with a 10 node cluster node. Tomorrow I want to increase it to 1000 node or 10,000 node also. The scalability of Hadoop is like what possible. This scalability is called as a vertical scaling and horizontal scaling. There are two type of scalings will be there. Vertical scaling, horizontal scaling. So generally big data technologies will follow the horizontal scaling. What is horizontal scaling is like what, instead of going with the one system, you will add n number of systems based on your need. So that approach is called as a horizontal scaling. The database world, people will follow like what, vertical scaling. What do you mean by that one is like what, increasing your hardware now. So today I have 16 GB RAM, maybe it's not sufficient, means like what, I have one more memory slot is there, I'll add one more 16 GB, 32 will be coming now. Like that, vertically increasing the existing system hardware some extent is called as a vertical, without disturbing that system like what, adding a one more system is called as a horizontal. Big data technologies mainly follow the horizontal scaling. Due to that, we can able to solve the first problem what we mentioned like what, storage problem, storing a terabytes, petabytes, exabytes of the data also it is possible. The beauty of Hadoop HDFS like what, it handles things in an automatic fashion. There are so many other internal concepts are there, I cannot go right now, but the main purpose is like what, it provides the reliable storage. It provides the reliable storage for terabytes, petabytes, exabytes of the data, maybe structured, semi-structured, unstructured data. It might be coming in a 1 day or 1 hour itself, doesn't matter. Hadoop having a capability of in HDFS storing the data now. Is that point everyone is clear? Any question on this statement? Hope all are clear. Okay, good. So the next point is like what, once we store the data, as I said, like what, we have to process it, otherwise there is no use now. Okay, so we need to analyze the data, then only we can do anything on that. In older days, like what, people use it to maintain some books now. Why? Because like what, based on that information, like what, so they can do some kind of improvements now. Okay, but now the books is not the one, because the volume is like what, more than that one. Now we are storing the data in a hard disk now. So whenever you are storing the data in a hard disk, if you keep it for 10 years, 20 years, there is no use now. We need to do like what, real time analytics now. Okay, so like an example is, you went to Amazon, so you look for some item now. So what Amazon people will do, like what, based on your logged in information, like what, they'll capture like what activities you are doing in their website now, or application. You clicked on this item, you clicked on this item, you clicked on this item. So they capture that information, like what, based on that, next time whenever you open the app once again, like what they says, these are the items maybe you're interested, these are the items maybe you're looking for. So they will give you upfront some information only, but how they can give like what, whatever the information we just observed by the website, like what, they take that information, they store it, they analyze it. Next time whenever you logged in, like what, they will going to give you the recommendations now. So that is a place like what this big data technologies people are playing it now. Okay, so here what is map reduce is like what, so whatever the huge amount of data we stored in HDFS, if you want to process it, you can able to process. Okay, so but how MapReduce will work is distributed parallel processing. How MapReduce technique here is like what, distributed parallel processing. We have sequential processing, parallel processing, but I'm not saying these two things. There is something else we are talking about in MapReduce is distributed parallel processing. So how it will be differ now? Okay, example is, I have huge amount of data. I'm doing in a sequential processing. Assume it. The sequential processing is taking 100 hours. Sequential processing is what? One by one. First 1 hour something, the next 1 hour. Like this, after 1 hour, the task is completed. That is sequential processing. But if I want to improve that one is, I can turn parallel processing. If I turn parallel processing, like what, instead of going by one worker, I will take 10 workers now. Then what exactly this 10 workers will do, like what, so this 100 hours will be like divided into a 10 10 10. So that means like what, instead of spending 100 hours now, each worker will spend only 10 hours. At the end, I'll be able to calculate what I need it now. So that means with parallel processing, I'm able to achieve it in a just 10 hours only. But what is the again technique of like what, distributed parallel processing is like what, you have n number of systems. In all the systems, like what, run parallelly. And also in each system also, if there is a possibility of parallel processing, that is what, like what, okay, if there is a possibility of parallel processing, you do it now. So then what will happen, like what, this 10 hours can still reduce it to like what, 1 hour also. The main purpose of distributed parallel processing is like what, your processing time will be going to reduce to, because you are not dealing with a small data, you're dealing with a huge amount of data. The reports getting it also, it is time taken, there is no much use now. Okay, that's the reason like what, we need to solve that problem like what. So Hadoop MapReduce come up with the answer for that, like what, distributed parallel processing. Why people started accepting the Hadoop is like what, one of the main reason is this MapReduce only. Okay, I'll give you the one realistic scenario what is happened in 2008 and 2009 now. In 2008, 1 TB data Hadoop is sorted in 3.5 minutes. In 2009, 1 TB data Hadoop is sorted in its improved version of the Hadoop 63 seconds. Okay, so why I am giving these inputs here now, you need to understand the importance of this open source technologies also. This is the primary point to give you idea. Okay, so these benchmarks, These are the world best benchmarks at the time of 2008 2009. You can also verify it in online now. So these benchmarks will be available, and these are published by the Yahoo company in 2008 2009. These benchmarks are published by the Yahoo company now. Yahoo is the main contributor for Apache Hadoop now. So why we are learning Hadoop is because of Yahoo. I'll explain that in the our main course, history of the Hadoop now. Okay, so but what I want to point today here is like what 1 TB data is not a small data. Okay, that too in 2008 2009. It's almost like what 10 years back now. Okay, 1 TB data storing is also a challenge, and processing is also a challenge now. The traditional solutions, whatever we people are playing it like what commercial things, maybe Oracle, Teradata, all those kind of applications like what they are not able to process this data in a day itself also. This 1 TB data, but Hadoop can able to do it in a just in a 63 seconds, and that too it is a freeware. You no need to pay 1 rupee to Hadoop also. But Oracle, you have to pay if you want to use it now. You have to buy the license now. Okay. But here it's a freeware. Okay. So then most of the people are thinking about like what, why don't we start utilizing this Hadoop like what as part of the large data to handle now. So small data, we will go for the traditional solution. But when the data is very large, why don't we use this Hadoop now? Like that from 2008 2009 onwards, like what people started using like what these big data technologies, and almost in initial days like what people are struggle now. The main reason for that one is like what, if someone want to solve this problem, they have to write the solution in Java. This is one of the biggest challenge in initial days, not today. Okay, so if someone want to solve this problem now, they have to write a Java program. So who are from like what programming knowledge like what they can, but who are from like what data science background, or maybe who are from like what data warehouse side now, who are like what maybe just admin skill set now, they are not able to solve this one, because Java is like what at that time people are like what very basic knowledge the people are having it. With that they are not able to. That is a challenge now. And then later what happened like what, people started building like what solutions on top of the Hadoop. Those are called as a Hadoop ecosystems now. Call it as a some tools now. So with the help of these tools like what, writing this Java program is not a mandatory. Okay. So as part of this discussion now, I'll talk about that. But main thing is like what I want to convey here is like what MapReduce. If suppose someone want to solve the problem in MapReduce, they should have a Java knowledge, but nowadays it is not required. Keep in mind also what is the initial days I'm explaining, and nowadays I'm clearly saying it is not. Java is not a mandatory. But what Hadoop MapReduce is that. Then second next thing is like what yarn. What is exactly this yarn is resource management, just like a manager role now. If you have a company and there is a product you are building it like what, the product manager is not there. So what is the challenges like what, we can't say deadlines on that product like what. So what are the requirements like what, how much is completed, everything is very hard now, because employee just will do his own task only. Okay, but the challenge is like what 100% concrete information we cannot be given now. So some resource management is required now. In big data Hadoop also like what, we have one resource management concept is, yeah, just like a manager now. Okay, you submit a one task now. You submit a one task. Is that task is completed or not? Is it going or not? We want to keep track of that information. Is Yarn is taking care of that. The main purpose of Yarn is resource management. So how many systems you have it now? How many resources are utilized in that system? Okay. Can I take new task or not? If not, okay. So I have to give instruction to them like what? Wait for some time. So this all kind of resource management activities will be taken care by Yarn. The combination of HDFS and MapReduce Yarn is called as a Hadoop. In this course, first we will be learning these three things. Then after that, so we will be start learning the ecosystems now. So before I talk about the what is ecosystem and how it will work now, any questions related to the Hadoop? If any point is not clear, please let me know. I'll clarify once again. So let me take one question from everyone now. So just to give an idea. So can you please tell me like what exactly SDFS is meant for? Just to confirm it, like what are we following or not? Okay. Can you please someone in one line statement like what is the main purpose of SDFS? Why we have to use? Anyone want to share their thoughts? Just now we discuss, correct? Please be interactive. That way, like what I know how much you are following it also. Okay. So why we need to go for HDFS? Just one line statement. Hitesh, Naveen, Prakash, Sridhar, please. Anyone? Can you hear me? Everyone? I hope I'm audible. Yes or no? Am I audible? Hello. Can you all hear me? Can someone unmute or like put the chat box? If am I able to hear you or not? Hello.
Yes,
Can you
sir.
all hear me?
Yes, sir. Yes,
Okay.
sir.
Okay, fine. Thanks. Fine, no issues. Okay. So let me continue what I want to discuss here now. The next important thing, like what we need to understand in Hadoop is like what Hadoop ecosystem. So there are different ecosystems. We have it here is Hive, Pig, Spoke, Flume, Kafka, Cozy, HBase, Sandra, MongoDB, Spark. Like this, there are so many technologies we have it now. Okay. So what are these exactly? They categorized into based on the requirement now. Suppose if we are going for like what some ETL activities now, high peak scoop is the primary. If we are going for streaming concept wise, Flume and Kafka, Storm like this. If we are going for scheduler, then we have a concept of, I'm just defining it now, I'll explain this. And if you are going for like what database aspect, no SQL concepts are this. If we are going with in-memory concept, Spark is like this. So what are exactly these technologies now? How it is helping to solve the big data problem? Let me explain now. Okay. So as I said, like what these are ecosystems. Ecosystems is like what once you have the Hadoop is running, on top of that are utilizing the Hadoop libraries like what people are build most of these ecosystems and parallel to Hadoop are integrated to Hadoop also. Okay. So the ETL part of the Hadoop is like what Hive, Pig, Scoop. What are these three things is if we are going for Hive, we will write an SQL query that will be translate into a Java program. If you are utilizing the Hive means writing a Java program is not a mandate. Writing a MapReduce program in Java is not required. Okay, you just write in Hive SQL that will be translated. The Hive tool is meant for that. Similarly, if I go for Pig, like what Pig scripting will be there. No, with the help of this Pig scripting, like what you will just like what write the script. No, Pig will translate into a Java. And if we are going for scoop, like what we will be having a scoop commands will be there now. So these commands will be translated into Java. So what is the primary advantage of this Hive pick scoop is like what you will be just writing one line of query or script or command. But what these tools will do, like what that one line equivalent Java code is going to generate, that might be like what more than 100 lines of code also sometimes. More than 100 lines of code also. So think about like what writing 100 lines of code is a time taken. But instead of writing 100 lines of code, what these tools are doing, like what simply in a one line you are able to write now. So what is the advantage is your development time will be faster. Your development time is faster because you're just writing a one line instead of writing 100 lines now. You're just writing in a one line now. Examples like what maybe select star from student, or maybe where id greater than 100 and is less than 15, something. Okay, so you will be writing some SQL query or maybe pig script or maybe scoop command now. So whenever you write this query, like what these tools will do, they translate into a map reduce program in Java. So for this one maybe 100 lines of code or more above will be there now. But I am able to write it in a very short, I mean less than 1 minute I'm able to write. But writing that 100 lines will take for me at least like about half an hour, maybe 1 hour now. So that means my development is faster here. I can able to develop within that 1 hour like what so many tasks. And also if there any mistake in this one line, easily I can look at it, I can answer. But looking at 100 lines, it is a more time taken. The main purpose of these tools are meant for like what to develop the things are faster in a short interval time. In a short interval time you will be doing the more productivity. Hope everyone is clear on that statement now. And also one more thing I'm saying here is like what it's not a mandatory to know the Java. If you are utilizing these technologies now, not mandatory to know the Java. Before 2013, before 2013, like what Java is the mandatory. But from 2013, almost like a last 10 years, like what Java is not a mandatory in big data. The reason is there are plenty of ecosystems or people are build alternative to Java way to handle now. Like Hive is in a SQL style, Pig is in a scripting style like this. Like what we have a alternatives in a short time only you can do it now. So hope all are clear on this point now. Any question on this before I go to the streaming concept? Okay, good. So let me go with the next concept is streaming. So this is very trendy nowadays now. So the examples like what we are using like WhatsApp, Telegram, or Amazon, or Flipkart, or YouTube, or Amazon Prime, whatever the technologies you are using right now, like what in all those places, like what the streaming concept is there. Like in previous example also, whatever I discussed now, that is comes under streaming only. You're doing some activities in like what Facebook, you're doing some activities in LinkedIn or maybe Amazon website. What they are doing, like what in a realistic manner, in realistic manner they are capturing the information. To capture their information, like what they are utilizing the these type of technologies now, Flume, Kafka, Kinesis, Storm, like these technologies are there. No, main purpose is to capture the real time events, to capture the real time events now, like a maybe ATM withdrawal now. Okay, maybe phone pay transaction now, whatever you are doing it now, those are all like what comes under the streaming operation. Flume and Kafka is the main thing, like what most of the people are using in the big data for streaming operations now, to do real time streaming. And keep in mind, they don't have any storage, they are just like a brokers now. So they collect the data and give it to someone, just like a courier boy now. Okay. So source to destination, he has to deliver the product now. Same technology like what the streaming concepts will follow now. So they just take the information from the source and transfer to the destination. Like that is like what the streaming technologies are there in the market to solve that one now. As part of this course also we have to learn this now. And the next thing is like what scheduler aspect now, just like an alarm concept now. The scheduler concept is like what, like an alarm now. So every day, every month or every year certain time I want to do some activity, it's very hard like what manually to do now. Okay, so what is exactly Uzi or Airflow, there are the technologies in big data, what they are doing is like what mainly to automate these things now. Okay, so instead of doing it manually, like what, you just define them and trigger it and forgot it, it automatically take care of it, like what, running it like what in a periodical fashion schedulers. So this is also like what one time activity you will be always playing in any big data project now. So you don't spend daily, but you just define it. Like an example is every day I need to set an alarm now. If I set today itself like what for next 1 year now, that is enough. Every day it will going to give a alarm ring to me. The same concept now here in scheduler, you define something like what for next 1 year or next 10 years, like what you want to do it, then automatically the task will be taken now. So it will reduce the manual effort. So we also need to understand the this scheduler concept now as part of this, like what Uzi, Airflow, this kind of technologies will come now. And the next very important, and everyone should have at least the basic knowledge on these technologies here, is like what HBase, Cassandra, MongoDB comes under concept of no SQL. What is exactly this no SQL means? Not only NO, not only SQL. So these are primarily alternatives to our RDBMS. Hope you remember like what in the starting of the discussion I said like what in RDBMS we cannot able to store like what large amount of data, we cannot able to process it now. Okay, but when it come to this NoSQLs, like what I can able to store terabytes, petabytes, exabytes of the data, and I want to process them also, I can able to process it now. So that's the beauty of this NoSQLs now. Already in Facebook, LinkedIn, all the places they are using it now, we are practically feeling it also. Okay, the Facebook only implemented like what Cassandra, one of the NoSQL what I written here is like what Cassandra is implemented by the Facebook, and HBase they are also using it now. MongoDB, if you go with like what mobile applications like what WhatsApp, Telegram, food application like what maybe Zomato, all these things they are primarily playing with like what MongoDB. Maybe if we are going for like what any graph theory kind of solutions also, like what in this NoSQL concept, like what there will be. Okay, we also need to have an idea on the these NoSQLs to store the huge amount of data beyond the RDBMS, beyond the RDBMS whatever it is there, like what we can able to store it in a these databases. These are the databases now we can able to store it now. And apart from this, the trendy thing in the market right now is like what's Spark. This is the in-memory computation. So what is exactly this Spark is like what primarily meant for processing. What type of processing is distributed parallel processing. When I say distributed parallel processing, we also discuss one concept is MR. But how it will differ from MR is like what MapReduce will do disk level processing. MapReduce will do disk level processing, but Spark is not disk level. Spark is like what it supports the in memory. Due to this, like what Spark is 100 times. Spark is 100 times faster than the MapReduce. That is the reason like what nowadays people are not writing the programs in MapReduce in Java. Instead of that, they are writing the code in the Spark now. So people will say like what big data means Hadoop and Spark, they say no. The reason is like what Hadoop is meant for the storing, and processing wise they are not going with the MapReduce now. Processing wise nowadays they are going with the Spark now. Okay, and Yarn is the resource management as it is now. So this combination is like what more powerful than the map reduce now. Hope all are clear on this point now. Okay, so as part of this course also like what, so how exactly Spark is working now, and how people are using, how to integrate with the technologies what we are learning in the first one is like what Hadoop and Hive and HBase or Cassandra or Flume or Kafka, whatever we are learning first now, how to integrate with the Spark also we will be learning in the our Spark course now. Okay, so that's a combination is like what our entire course now, so Hadoop and as well as Spark. So we will be taking this course like what approximately like what 4 months now. So it will be like every day 1.5 hour now. So morning 7 to 8:30, Monday to Friday you will be having like what morning 7 to 8:30. So on Saturday Sunday will be like what you will be having like what 2 to 3 hours, depends on like what the complexity of the topic was, and also revising the things, those will be happen in that long duration. But that way like what it will be going to be more easy for people to understand the concepts now. So that is a plan of the course now. And coming for this course, entire end to end, like what I'm the only faculty, I'll be taking care of it. If you have any questions now, you can feel free to ask me. I'll answer them. And if there is no question, I'll hold it here. Any questions? Anyone have it now?
Hello, sir.
Yeah, please.
Hello. Sir, my name is Hitesh. I am a fresher, just 2023 passed out candidate.
Okay.
Uh, yeah, is it good for me to choose this course? Means, will they hire freshers like me?
Okay. Good question. Okay. So the technology right now, what we are learning is like what is it for fresher or senior is not the one. What exactly company need? Suppose now I hire you as part of my project now. Okay. Now we are working on the big data. And I also hire you like what having a 5 years experience guy. I also hired like what 10 years experience guy. For all these people, I hire for what big data project. Okay, now if you want to work as a fresher has to work in that project, and as software engineer also need to work, senior software also lead, all has to work on that project now. Okay, but based on their experience like what the task will be different now. Okay, so without this knowledge you may not be, that's the only thing now. So the way they assign a task to you is like what little bit low level, who are having is like what more experience, he has to manage the team and he has to do some extra stuff like that. It doesn't
Oh,
mean like what only senior people has to learn this technique, not every company is like what who are dealing with the big data, who are dealing with the big data, they need to use these technologies. That means they should have this knowledge now, then only they can solve the problems in their project. Hope you understand that point.
yes, sir.
Yeah.
And sir, uh, that program regarding programming language, uh,
Mhm.
uh, mm, at least we don't need to learn any programming language, or if we have it, it will be helpful.
Good. So coming to in big data, like what first primary thing is like what most of the projects are people are using it like what SQL. SQL knowledge is required now. It's not like a PLSQL knowledge is not required. Basic SQL knowledge, anyone can get that basic SQL knowledge like what create, update, select group by order by this kind of queries like what it will be there in basic SQL no, in a span of like what 2 3 days to maximum week time. Anyone can get that basic knowledge. Okay, that is the first thing. So that knowledge is common for entire big data and non-big data also people are who are playing now. And the second thing is like what one programming knowledge always good if we are going in like what as a data engineer or a data scientist, or maybe if we are going as a DevOps other place, depends on the what exactly role you are going. Suppose I want to go as a data engineer now, maybe good to have it like what some Java and the Scala or Python. One of the programming language like what skill set is good. If you are going as a data scientist now, okay, then the data scientist people will be learning like what Python and R now. and who are from like what DevOps, like what they will be having like what Unix scripting and Unix knowledge, no, like that. So depends on their role wise, like what one programming knowledge with SQL is like what common, it's common for, because otherwise we cannot do anything now. Okay, so I have a knowledge now, but I don't know how to write that program also, it is not acceptable, correct? At least one programming knowledge is like what basic knowledge as a fresher means, like what basic knowledge at least required now as a senior people could strong on that as much as now. If that is there, but really that much knowledge is to learn to big data means no. Learning
Okay,
big data, that much strong knowledge is not required. Okay, very basic knowledge is also sufficient to learn the big data now, but maybe some requirements may demand you like what, then you may google it like what, or you take help from some senior resource, that's fine, but at least basic knowledge is mandatory. Okay,
okay, sir. Okay,
yeah,
sir. And
because we
in
want to
our curriculum,
survive it, right? We want to survive it means at least the basic knowledge is required. Yeah.
yes, sir. And in present in our curriculum, in what language that Spark is going to be taught?
Yes. So Spark we'll be going to teaching in the primary in Scala. I'll explain the what is Scala and how to write the, as I said, basic note till that level I also explained. And also we'll also cover the use cases of like what PySpark note. As part of that, like what basic Python knowledge will be given, and we'll be going to talk now. Both the things too. So
Okay.
Scala,
Scala and
Python. With Spark you will be learning it now.
okay.
Okay.
Okay, sir.
Yeah.
Thank you.
Thank you. Any other questions? Anyone else having it? Naveen, Prakash, Sanket, Subbu, Vaishnavi. Okay. So if you don't have any questions now, then just feel free to talk to the management now. So they just maybe you can call them or they call back to you. And we will be planning the course like what from this Wednesday onwards now. If you just give the input on that, they will be going to plan as per that until they continue the course now. Okay, so make sure that like what, so just discuss with them, and if you have any other questions I can stay for some more time, otherwise like what, I'll hold the session here. Okay, thanks everyone for joining. Bye.